All right. So last time we talked about limit laws, and then today we're gonna do some more practice problems. So last time we said that when you have function fx and gx, and then you wanna compute the limit of the combination of fx and gx, you can use limit law number 1 to number 8 here. So you can use number 1, number 2, number 3, number 4, number 5, 6, 7, and 8 here. So when I ask you to do limit problems, you can start by the given problem, and then you can just skip the step that I box in green here, and then you can just show your work by just show the one that I highlight in yellow. That's all we need for using limit laws. Today we're gonna do more examples. So let's move to some complicated example. All right, we're gonna move to example 6. All right, so example 6, I want you to evaluate limit of square root x plus 4 minus 2 over x squared minus x. First of all, when you see the problem about computing limit, so you can try to plugging in the number. Here I know that x approach 0. So I will try to plug in number 0 into the function. And then this is going to be square root 0 plus 4 minus 2 over 0 square minus 0. And then if you compute this thing, you're going to see, hey, this is 0 over 0. So it is not a real number. So, well, you have to use other technique. Just using limit law does not make sense because your answer is going to be 0 over 0 and this is not a real number. So you have to do something else. And last time we show you how to do factoring. So one thing you can do factoring if you want. Well, we're going to show you other technique today, which is called conjugate. So conjugate is the thing that we can use when you see something like, for this question, you see square root a minus b, which is the term that I see in the numerator here. When you see this thing, you can multiply this function by its conjugate, which means the conjugate of square root a minus b is square root a plus b. So what are we going to do is we are going to multiply this function by its conjugate and then hope that something cancel at the end and then we can compute limit easily. So for here, so what I'm gonna do here is I'm gonna start by multiply by its conjugate. So it's gonna be limit when x approach 0 of square root x plus 4 minus 2 over x squared minus x. This is just your original problem. And then I am going to multiply by its conjugate, which is square root x plus 4 plus 2. This is its conjugate. I just switch the sign from negative to positive, right? And then when I multiply by this thing, so I have to make sure that everything keeps the same. So we are going to multiply by number 1. So that means I have to multiply by square root x plus 4 plus 2 both on the numerator and denominator. This is because we want the term that we multiply here to be 1. So the value does not change. And then after that, once I multiply its conjugate, so I can simplify it. So the good thing about this question is once you multiply the conjugate, you can use the identity that a minus b times a plus b, this is equal to a squared minus b squared, right? And then your square root x plus 4 gonna multiply 2 times, so you get x plus 4. And then your negative 2 and plus 2 gonna multiply, so you get negative 4. And then on the bottom, so I have x squared minus x, which I can factor to be x times x minus 1. And then this is going to be square root x plus 4 plus 2. Well, it seems pretty good now. So we are going to do some cancellation now. So you can see that 4 and 4 cancel, right? And then I have x left. So x here gonna cancel with x in the bottom. And then after that, I have 1 over x minus 1 times square root x plus 4 plus 2. And then I use the limit law. But when I use the limit law, I just skip some steps. I am not going to show you all the steps of the limit law. So I'm going to just do like this: 1 over 0 minus 1 square root 0 plus 4 plus 2. All right. And then after that, I get the answer, which is 1 over negative 1 times 4, which is negative a quarter. And that is all for this question. So for sure on the exam and on the homework, you're going to see one question about conjugate. So you can compute the limit by using the conjugation. So make sure you practice on this thing because, yeah, well, very likely that you're going to see one question about this thing every semester. All right, so let's do more about conjugate problems. So example 7. So what I'm going to do is I am going to multiply this thing by its conjugate. So first of all, I need to multiply by number 1, right? And then its conjugate is 4 plus square root 16 plus x over 4 plus square root 16 plus x. Well, again, conjugate, you just change your sign. And then the reason is because we are going to multiply them together, and then we hope to see something that is nicer and something that you can cancel. All right, next step, we are going to multiply those things on the top together, and then we're gonna get 16, which is 4 square, and then minus square root 16 plus x 2 times, which is going to be just 16 plus x. And then after that, on the bottom, I have x times 4 plus square root 16 plus x. Well, this is going to be something easy again. So 16 gonna cancel with 16, right? And then you have negative x on the top, and then negative x gonna cancel with x. So you have negative 1 left. And then in the bottom, you have 4 plus square root 16 plus x. And then once you replace x by 0, so you're going to get negative 1 over 4 plus square root 16 plus x, which is going to be tick-tock, square root 1 over 4 plus square root 16 plus 0, which is going to be negative 1/8. Well, let me check if it matches with my note. It should. So, well, if you see something wrong, you can just stop me. Well, sometimes, I'm too excited and then I just miscalculate something, but this is correct already. Good. All right. So that is the problem about using conjugation. All right. So we're going to do some more problems. All right. Other than using some technique about factoring or conjugation, so we're going to learn new technique on this slide. So the next technique is using the squeezing theorem or squeeze theorem, or sometimes called sandwich theorem. So the squeeze theorem or the sandwich theorem. So let's see the statement of this theorem. So theorem, well, let f, well, g and h be functions from the domain D to real number R, where the domain D is a subset of R. Well, if we know that fx less than or equal to gx less than or equal to hx for all x in the domain except the point A, and limit of fx when x approach A equal to L, and limit of hx when x approach A equal to L, then this is what you can conclude: limit of gx when x approach A is equal to L2. So this is the statement of the Squeeze theorem or sandwich theorem. The key point is when you have the statement here, fx less than gx less than hx, what you can do is, if you know that limit of the lower bound function is L and limit of the upper bound function is L, then you can conclude that the limit of the function that is in the middle is also L. This is why, people name it sandwich theorem or squeeze theorem, because it's squeeze that function g must have the same limit, because function f and function h have the same limit, which is equal to L. So g must be equal to L too. If you see the picture here, you can see that, hey, my function f is here, my function h is here, and then I know that my function g here is in between function f and h all on every point in the domain D. So if you see the situation like this, at the point A here, I want to find the limit of gx. I can do that by using squeezing theorem or squeeze theorem or sandwich theorem. This is equal to L. Well, we're going to see the real problem in a minute, but this is the theorem. So it is going to be useful when you face some trigonometry. All right, so let's look at example now. So example 8. So let's do this question together. So this is going to be your first problems about squeeze theorem. So I'm going to show you how to do the full solution. So example 8, use the squeeze theorem to find the exact value of limit of x squared times cosine 1 over x squared. So first of all, if you want to get started and then you know nothing about squeeze theorem, you can try to plug in number 0 here. So you're going to get, well, if I try to plug in number 0 here, I'm going to get 0 square times cosine 1 over 0 square. And then you're going to see that, hey, อาจารย์ครับ 1 over 0 square is undefined, right? In mathematics, you cannot have something 0 in the bottom. So here, this is undefined. So some of you are going to say, hey, I'm going to answer that limit does not exist, which is wrong. Well, you don't know yet. So what I'm going to do here is we're going to use the squeeze theorem, because the problem asks us to use the squeeze theorem to compute this thing. So let's see how to do it. So the idea is, all right, solution. So what I'm going to do here, I'm going to start by using the property of cosine function. So I know that, well, this is from your high school trick. So recall, this is your trick background. So you know that sine function and cosine function of anything can be in the triangle here, this is going to be bounded between -1 and 1, right? So sine function and cosine function is going to be between -1 and 1 all the time. This is sine function, right? And this is cosine function. So you can see that sine and cosine, no matter what x is, so the range is going to be between -1 and 1. So we're going to use this property to do this problem. So we're going to say that, hey, I have cosine of 1 over x squared. Well, it doesn't matter what is inside the parentheses. So this is between -1 and 1 by property of logarithm. Oh, sorry, by property of cosine function, not logarithm, of cosine function. Does it make sense? And then we're gonna multiply everything by, next we're gonna multiply everything by x squared. So if I multiply everything by x squared, multiplying by x squared yields, so negative x squared less than or equal to x squared times cosine 1 over x squared, and then less than or equal to x squared. So I just multiply x squared to the inequality. And then after that, I can see the pattern now. This is my function g, right? This is my function h. This is my function f. So I have an inequality that fx less than or equal to gx less than or equal to hx. Well, and after that, I compute limit of fx when x approach 0, which is going to be limit of negative x squared. And then this is negative 0 square, right, which is 0. And then I also compute limit of hx when x approach 0. This is going to be limit of x square where x go to 0, and then this is 0 square, which is 0. Bam! The good thing is you got the same number. Perfect, right? From here, we can conclude by the Squeeze Theorem. We conclude that limit x squared cosine 1 over x squared when x goes to 0 is equal to 0. Well, this is how we use the Squeeze Theorem, and this is what we expect from you to write a full solution like this on the exam. If you skip step, well, you probably lose your point, and then, you know, if I cannot follow your work, you lose your point. So that means you have to show the full step like this. So you have to make sure that you write the whole inequality, and then you take limit on the upper bound function and lower bound function and mention the squeeze theorem. Does it make sense? This is called squeeze theorem or sandwich theorem. All right. Sounds good. So any questions so far, you can leave your question in the chat. All right. So we're going to move to another 3 example, which is, they are all exam. So we're going to just look at all exams. So to show you, this is the difficulty level that you're going to see on the exam. All right. So we have example 9 here. We have example 10, and we have example 11. So this is a mixed question that I copy from the O exams. I adapt a little bit, but you can see that this is the same difficulty level that you're gonna see on the exam for this class. So let's do this 3 problem, and then we are done for today. So any question before we get to example 9? So type in the chat, please, if you have any questions. All right. Okay, so let's start by example 9. So example 9, I want you to compute limit of fx when x approach 2. All right. Given the function f as you see on the slides. All right. So what we're going to do here is, because I want to compute limit when x approach 2, and then I see that the function is defined as a piecewise function. When x less than 2, I use this thing. When x is greater than or equal to 2, I use this thing. So that lead me to compute left hand limit and right hand limit, right? That is what you expect to do. So the left hand limit is this. So we're going to compute the left hand limit first. And then after that, we're going to compute the right hand limit. And then we're going to check if they are equal to each other. So let's start by the left hand limit. So for the left hand limit, the function that you're going to use is going to be the function on the first condition, which is the one that I highlight in green here. So it's going to be limit of absolute value of x squared minus, plus 3x minus 10 over x minus 2. And then x approach to from the left. First of all, well, when you see the absolute value, you have to take the absolute value off, right? So how do we get it off the absolute value? So we're going to look at here. So I have absolute x squared plus 3x minus 10. So this is going to be plus x squared plus 3x minus 10. Well, if this thing is bigger than or equal to 0, right? And then this is going to be minus x squared plus 3x minus 10 if x squared plus 3x plus 10 less than 0. So this is what you have. And then you want to get rid of this absolute value. So we're gonna see when x approach to from the left. So what condition that you need to use? And then the answer is going to be the second one, right? Because when x approach to from the left, so let's say that x is equal to 1.999999. If you plug in 1.99999, something that is close to 2 from the left into the inequality here. So you're going to see that x squared plus 3x minus 10, when x approach 2 from the left, that is less than or equal to 0. So that means you have to use the condition on the bottom. So that's why we take the absolute value off, and then I have negative x squared plus 3x minus 10 over x minus 2. You have to be careful when you trying to get rid of the absolute value, because when you just throw away the absolute value, sometimes you get positive sign, sometimes you get negative sign. So for this case, you have to carry your negative sign. And then after that, I'm going to factor the thing on the numerator. So I have negative x minus 2 and x plus 5. So everyone should be able to factor this thing easily. And then I cancel x minus 2. And then after that, I have limit x go to 2 from the left. And then that is negative x plus 5, which is negative 7. All right, I have the left hand limit here. And then for the right hand limit, I hope that we're going to get the same number, so we can conclude that the limit exists and is equal to that number. So let's try to plug in the number 2 there. So I have the cube root 3 times, well, I'm going to plug in number 2 there. So, well, using the limit law, but I call plug in because, well, because of the continuity that you're going to learn later. So this thing is equal to the thing, this thing is similar to the one that I trying to plug in number 3 here, or number 2 here. So I have that. So let's hope that this thing is a real number. All right, the cube root of, well, 2 square is 4, right? 4 times 3 is 12. 12 minus 4 is 8. 8. The cube root of 8 is 2. And then minus, so 2 cube is 8. 8 times 7 is 56. And then minus 24, and then, oh, sorry, plus 24 and plus 1. So that is square root of 81, which is 9. And then this is going to be negative 7 as well. So you have negative 7 on the left limit and right limit. So we conclude that the limit of fx when x approach to from the left, or no, approach to, this is equal to 7, or equal to negative 7, sorry. I talk too fast, but well, that is how we do this problem. Sounds good? So the idea is, yeah, when you see the absolute value, most of the time you have to compute left hand limit and right hand limit, because it forces you to do that, because when you take absolute value off, you have to figure out what condition you're going to use. And then if the left hand limit and right hand limit, they are equal to each other, your conclusion going to be that number, that real number. And if they are not equal to each other, your condition going to be DNE, does not exist. Well, this is the same level as you're going to see on the exam. All right, so let's do example 10. 2 more for today. So example 10. So let's evaluate limit of this thing. So how could you do it? So student gonna say, hey, Ajahn, I see the sine function here and I know immediately how to do it, which is good. We just learned on the previous example that if you see the trigonometry function, you can use the Squeeze Theorem or the Sandwich Theorem, right? Because that's gonna make your world a lot easier, because you're gonna make it bounded by negative 1 and 1, and then you're gonna see if it's possible to use the Squeeze Theorem. So if you don't know the Squeeze Theorem, so you can plug in x equal to 1 to the function first, and then this is what you're gonna have. If you're trying to plug in number 1 here, and then you can see that the problem is you have negative 1, sorry, square root 1 minus 1 on the bottom here, which is going to be 0. And then, hey, the 0 on the denominator is not a good thing, right? Because this is not defined. So, well, you cannot just trying to plug in the number. So, no. So what are we going to do is we are going to use a Squish Theorem. So keep in mind that, well, if you see the sine and cosine here, sine and cosine function lead us to the Squeeze Theorem technique. So we're gonna start by consider, well, sine of this thing is between negative 1 and 1. I don't care what is inside the parenthesis, so it's gonna be in between negative 1 and 1 for sure. And then after that, well, I try to divide everything by 2x plus square root x first. This is still good. 2x plus square root x, right? Because when x is bigger than 1, when x is bigger than 1, so 2x plus square root x gonna be a positive number. And then if you divided everything by positive number, So the inequality still holds, right? Because you have to make sure that the thing that you divided is positive, because if the thing that you use in the denominator here is negative, the sign gonna change to greater than or equal to sign, right? You have to make sure that the thing you attach to the inequality is positive first. So this thing is good now. And then after that, well, I want a little bit more to make sure that the term in the middle match with the one that I have in the problem. So I'm gonna multiply by x squared minus x, which is okay too, because when x greater than 1, x squared minus x gonna be the positive thing as well. So now in the middle, I have this thing, because I multiply it by x squared minus x. All right, I multiply it by x squared minus x. This is what I have. And then now, once you have up to this point, so you have what you want in the middle already. This is true when x greater than 1, which is match with what we have, because we want to compute limit when x approach 1 from the right. And then after that, you're going to compute limit of this thing, which is the left hand, or I mean upper bound, lower bound function. And then you compute limit when x approach 1 from the left, from the right. And then this thing now you can plug in number 1 and then you get the 0, right? Because you're gonna get 0 over some number, 0 over, what is that? 2 plus 1, which is 3, which is 0. And then you hope that once you compute limit of the upper bound function, which is x squared minus x over 2x plus square root x, hope this is going to be 0 to, and of course it is. So now you can conclude that, well, I mentioned a little bit to make sure the grader can grade your work correctly. So by the sandwich theorem, or you can call squish theorem, we have that limit of x squared minus x over 2x plus square root x times sine x square root over square root x minus 1 equal to 0 as well. Well, this is how to complete this problem. Is that too hard? No, right? Just super easy, huh? All right, so let's move to example 11. This is the last example for today, and then we're gonna start infinite limits on Monday. All right, if you are good with the content today, so type in the chat that, well, you okay with the pace here? So I know that the pace of the class is okay now, I think. Yeah, all good. Some of you say. Okay, I mean, I want to go a little bit faster, but I'm afraid that some of you gonna get lost. So, well, let's keep this pace first, and then, well, if we are think that we are all good, maybe we are going to increase the pace a little bit next time. So let's look at example 11. So this is supposed to be the I should say this is a little bit hard one for the exam, but still not that tough, but well, it is a challenge one. So let's look at this question, limit of 3 minus square root 7 plus square root x over 2x squared minus 7x minus 4. So I expect the student who want to get B plus or A to complete this question easily. So, well, this is not the basic question, but yeah, you have to do something a little bit, but well, not that hard. Okay, let's do it together. So first of all, when you see this thing, you can see that, hey, you have square root here again, And then every time I see something with square root here, and then I have 3 minus in the front here, I want to use conjugation, right? Because why not, right? So we're gonna do this thing, x approach 4, so 3 minus square root that. So, well, I just copy the question first, and then after that, I multiply the conjugation here. Oops, it must be t plus square root 7 plus 7 plus x over 2x squared minus 7x minus 4. So you can see that I have switched the sign from negative to plus when I do the conjugation. And then after that, you simplify it. So well, in the numerator, I have 9 minus 7 plus square root x, right? And then on the denominator, I have, oh, sorry, this thing must be 3 plus square root 7 plus square root x. So, all right, and then on the denominator, so you need that term, okay. I'm going to keep that term first, but well, eventually we have to factoring this thing anyway. So I'm gonna keep this thing first. Well, before you multiply the conjugation, I forgot to tell you that the first thing that you should do is maybe you plug in x equal to 4 to the function first. So if I plug in x equal to 4 here, so you're gonna see that on the top, I get 0. On the bottom, I also get 0. So that's why it end up with 0 over 0, and I have to use the conjugation technique. So up to this point, so I'm gonna plug in number 4 again. So if I plug in number 4 into this limit, so I am going to get 9 minus 7 plus square root 4. So on the top, I have 0. So on the denominator, if I plug in number 4 here, I still get 0, right? Because the term 2x squared minus 7x minus 4 still exists in the denominator. Well, it's still 0 over 0, so what should I do? So the thing is that let's simplify a little bit more. So what are we going to do is we are going to simplify 9 minus 7 to number 2, and then this is minus square root x. And then I am going to factor my 2x squared minus 7x minus 4 here. So I factor it to be 2x plus 1 and x minus 4. Well, you can try factoring by your own. So I did it too fast because I did it when I prepared the lecture already. So I did it fast because I have the answer with me now. So I factor this thing, and then you still see, yeah, you need something that you can cancel it, but so far you don't have it. So let's multiply conjugate another time, right? Because you have 2 minus square root x here. So I'm going to multiply by its conjugate another time. All right, 2 plus x. So if I multiply its conjugate another time, so on the top, so you're going to have 2 minus square root x times 2 plus square root x, which leave you 4 minus x. And then in the denominator, so I have 2x plus 1, 4 minus x. Oh, sorry, x minus 4. X minus 4. And then 3 plus that thing. And then 2 plus square root x. This is so good because 4 minus x is going to cancel with x minus 4, and then you have negative 1, right? So at the end, you're going to have, well, I'm going to plug in the number now. So negative 1 over 9 negative times 6, right? Because I plug in x equal to 4 here. So I get 3 plus square root 9, which is 6, and then 4. So you compute this thing, so you get negative 1/216. All right, this is your answer. So you have to use the conjugation two times to complete this problem. All right, that is a good practice for using conjugation two times. So for now, you have learned that. So to sum up up to this point, you have learned that if you trying to compute the limit of fx when x approach a, or if you get the 0/0 thing, well, you have learned that you have two technique already with you, which is factoring and conjugate. For those of you who already know the L'Hopital rule, some of you are going to say, hey, Ajahn, I know L'Hopital rule already. Can I use the L'Hopital rule? The answer is no. We're going to learn the L'Hopital rule on chapter 5. So we have not done it yet. So if you use the L'Hopital rule, it means you use something that we have not covered to solve the problem that we do not require you to use the L'Hopital rule. So you will not get the credit if you use the L'Hopital rule. You have to use factoring or conjugate. So if you know L'Hopital rule already, good, save it for later. So we're going to learn the L'Hopital rule in chapter 5, but for now, no. You cannot use the L'Hopital rule. All right? Well, I mean, you can use in real life, but for checking if you know how to factor and conjugate. So we want to check if you know how to use the factoring technique and conjugate technique. So we want you to use factoring or conjugate technique, not the L'Hopital rule. And then another technique that we learn is Squeeze Theorem or Sandwich Theorem. I like Sandwich Theorem more because I can see the picture of Sandwich Theorem by saying it is a sandwich. So that means if I have the inequality here, and then I know that the upper bound limit and lower bound limit, they goes to L. That's gonna force your G go to L too. That is the statement of the Sandwich Theorem. All right, so that is all for today up to this point. So we have a mental breaks here, and then on Monday we're gonna come back and do the infinite limits. So this is the, whoa, I laugh so hard when I see this joke, but I